So our chapter probability intended for grade 9 pupils, subject maths, chapter probability. Aim. The aim of this lesson is to solve problems involving probability. Objective. At the end of this lesson, students or pupils will be able to understand and solve problems involving, firstly, sample space, definition of probability, laws of probability, possibility diagram. So sample space or possible outcomes. Sample space, definition of sample space. Sample space is a set of all possible outcomes in a trial or experiment. So the set of all possible outcomes is called the sample space. An example, in each case obtain the sample space. Firstly, a fair cubical die is thrown. Part B, a fair coin is tossed. Part C, a letter is chosen from the word Singapore. So solution part A fair cubical die is thrown. So a cubical die has 6 faces. So a cubical die has 6 faces numbered 1 to 6. So the sample space means a set of possible outcomes is, we can have 1, 2, 3, 4, 5 or 6. So this is a sample space. Part B, a fair coin is tossed. So when we toss a coin, we have only 2 possibilities. So sample space is, so either we obtain, so sample space set of all possible values. When we toss a coin, we have only 2 possibilities, either the head or the tail. So part C, letters of the word Singapore are written on individual cards. So how many possibilities do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. The sample space is set of all possible outcomes. So we can obtain S, I, N, J, A, P, O, R, E. Now, probability. Our syllabus is simple probability. So definition of probability. Probability of happening of event A is denoted by PA, where PA is equal to number of favorable outcomes divided by total number of possible outcomes. So favorable outcomes means number of outcomes that are in our favor. So an example 1, if fair coin is tossed, find the probability of obtaining a head. Example 2, A fair cubical die is thrown. Find the probability of obtaining the number 4. Find the probability of obtaining a prime number. Example 3. A bag contains 5 red balls and 3 blue balls. A ball is drawn at random from the bag. Calculate or find the probability that the ball drawn is blue. So example 1, solution. A coin is tossed. Find probability of obtaining a head. So when we toss a coin, the sample space means the set of all possible values is head or tail. We have two possibilities. So probability of obtaining a head, using abbreviation we write P head or simply PH. PH means probability of obtaining a head. So head, we have one possibility out of 2. So in our favor is head. So 1 over 2 possibilities. So probability of head is 1 over 2. Example 2. A fair cubical die is thrown. The sample space, means set of all possible values, is 1, 2, 3, 4, 5, 6. Part A. Find probability of obtaining number 4. So number 4 means we have only one in our favor, 1 out of 6 possibilities. So probability of obtaining number 4. So probability number 4, we can further simply write it as, we can also write it as probability of obtaining number 4 is equal to number of favorable outcomes over total number of outcomes. So number 4, we have only one in our favor. So 1 out of 6 possibilities, 1 over 6. So probability of obtaining number 4 is 1 over 6 possibilities, 1 over 6. Part B. Find probability of obtaining a prime number. So what are the prime numbers out of 1 to 6? So prime number is either 2, 3, or 5. So favorable outcomes 2, 3, or 5. So probability of obtaining a prime number is 3 over 6 possibilities. So we have 3 ways that we can obtain a prime number. So when we throw a die, probability of obtaining a number prime is 3 over 6 possibilities, 1 over 2. Now a bag contains 5 red balls and 3 blue balls. So in all we have 8 balls. A ball is drawn at random from the bag. Find the probability that the ball drawn is blue. Solution, we have 5 red, 3 blue. In all we have 8 balls. Probability ball drawn is blue. So probability, we can simply write it as probability ball drawn is blue. We can write it as P blue, or we can also write it simply as P of obtaining a blue ball is P B. So number of balls in our favor is 3. So 3 out of 8 balls in our favor. So probability of obtaining a blue ball is 3 over 8. Now, next part. If A is an impossible event, then PA is equal to 0. So an example, if a cubical die is thrown, find the probability of obtaining the number 7. When we throw a fair cubical die, so the sample space is 1, 2, 3, 4, 5 or 6. We cannot have number 7. It's impossible. So probability of obtaining number 7 is 0 over 6. Not possible. So 0. So probability of an impossibility is 0. So the smallest probability that we can have is 0. A probability cannot be negative. Next, we have if A is a true event, then PA is equal to 1. So an example, a bag contains 8 red balls. A ball is drawn at random from the bag. Find the probability of drawing a red ball from the bag. So find the probability of drawing a red ball from the bag. So solution, a bag contains 8 red balls. All the balls are red. So probability of obtaining a red ball, so I choose a ball at random from the bag. There is no way that it's be another color. It's going to be red. So probability red is PR is equal to 8 over 8, 1. So this is a true event. So all the balls are red. What is the probability that when I draw a ball, the ball is red is 8 over 8, 1. So what do we observe is the smallest probability is 0. The largest probability is 1. So probability of happening of any event A is between 0 and 1. Okay, so smallest probability is 0. Largest probability that can be 1. If somewhere you obtain probability negative, means there is an error, you must verify. If you obtain probability of A 1.2, it is not possible. Highest probability is 1. So if probability, next part, if probability of happening of an event A is PA, then probability of event A not happening denoted by PA dash, where PA dash means probability of A not happening is simply 1 minus PA. So an example, probability of event A happening is 3 over 5. Find the probability of the event A not happening. Solution, probability of event A happen is 3 over 5. So probability of event A not happen is 1 minus probability of A happening, 1 minus 3 over 5, 2 over 5. Another example, the probability that it is rainy on any day is 0.2. So we do not know whether next Monday is rainy or sunny or what. So on average, the probability that it is rainy on any day is 0.2. Find the probability that it is not rainy on any day. So solution, probability rainy is 0.2. Probability not rainy is a contrary of probability rainy, means 1 minus probability rainy, 1 minus 0.2, 0.8. Now possibility diagram, we have two fair cubical dice are thrown. So when we throw one cubical die, we obtain 6 possible outcomes, 1 to 6. Now we are throwing two cubical die. two fair cubical die means we are going to obtain two numbers. So we can have two free or free two, they are not the same. So two free means two on first die, free on second die. Free two means free on the first die, two on the second die. We can also have 5, 6 and so on. So we are going to list all the possible outcomes. So firstly, draw the possibility diagram. Possibility diagram means the list of all possible outcomes. Secondly, find the probability of obtaining a double, a number 4 on first die and an odd number on second. Part C, a number 4 and an odd number. So solution, possible scores. So here we are going to use coordinates. So score on first die, score on second die. So score on first die, when we throw the first die, we can have scores either 1, 2, 3, 4, 5 or 6. Second die, we can still have 1, 2, 3, 4, 5 or 6. So here as coordinates, same as coordinates, we can have 1, 1, 1, 2. Okay, so coordinate geometry, x, y, x, y. So 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, and so on. So we have a pattern 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So how many possible outcomes do we have? So firstly, this is one possible outcome, 1, 1. This is 1. So we have 6 by 6. In all, we have 36 possibilities. So when we throw one die, one cubical die, 6 possibilities. When we throw two dice, means 6 by 6, 36 possibilities. First part, probability of obtaining a double. So in all, we have 36 possibilities. All our probabilities are on 36. So probability of obtaining a double, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6 means 6 over 36, 1 over 6. Probability number 4 on first die and odd on second. So number 4 on first die, so here all possibilities where first die is 4, and odd on second. Second odd means 4, 1, 4, 3, 4, 5. So we have 3 such possibilities. 3 over overall, 36 possibilities, 1 over 12. Part C. Probability a number 4 and an odd number means a number 4 means it can be that the first die is 4 and second is odd. So it can be that the first die is 4 or it can be that the second die is 4. So first is odd. So 1, 4, 3, 4, 5, 4. So here in all we have 6 possibilities over 36, 1 over 6. Now possibility diagram still, example 2. We have two fair cubical dice are thrown. Find the probability that the sum of the resulting numbers is odd, even, or the sum is prime, or the sum is a multiple of 4, or the sum is at least 7. So here, 2 fair cubical dice are thrown. 1, 2, 3, 4, 5, 6. Second die, 1, 2, 3, 4, 5, 6. Here we are counting sum of scores. So when we obtain 1, 1, the sum is 2. So when we obtain 1, 2, so 1 on first die, 2 on second die, so the total is 3. So and then we have a pattern 4, 5, 6, 7. So 2, 1 is 3, 2, 2, 4, 5, 6, 7, 8, 9. So 3, 1, 4, 5, 6, 7, 8, 9. 4, 1, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. So 6, 1, total is 7, 8, 9, 10, 11. When we obtain 6, 6, maximum score is 12. So the minimum score is 2 for 1, 1. Maximum score is 12 for 6, 6. Find the probability that the sum of the scores is odd. Sum is odd means it can be 3, 5, 7, 9, or 11. So when we count, we have 18 possibilities over 36, 1 over 2 in simplest form, or 0.5. Part B, probability sum is even. So even the remaining numbers, so even 2, 4, so 2, 4, 6, 8, 10, or 12. So when we count, we obtain 18 over 36 possibilities, 1 over 2. Part C, probability the sum is prime. So prime numbers start from 1 is not prime. So prime numbers 2, 3, 5, 7, 11, and so on. So here prime numbers 2, 3, 5, 7, 11. So when we count, we obtain 15 possibilities over 36, 5 over 12. Part D, find probability the sum is multiple of 4. So probability the sum is a multiple. Multiple of 4 means multiplication table. Multiples of 4, 4, 8, 12, and so on. So here possibilities, multiples of 4, 4, 8, 12. So when we count, we have 9 over 36 possibilities. We simplify, we obtain 1 over 4. Now part E, probability sum at least 7. At least 7 means the term at least means greater equal to. So the sum at least 7 means the sum is at least 7. Greater equal to 7 means 7 or more. So these are the possibilities. So when we count, we have 21 possibilities over 36 by 3, 7 over 12.